talking about a mission to Mars and what we would need to consider to colonize Mars. We're going to do that over the next 2 class meetings. Before we start on that, though, I wanted to give you an opportunity to look over your tests, which you may or may not have seen has been graded. If not, then just pull up the tasks list for today. It should be both posted as an announcement and assignment. Today is Unit 5, Lesson 8, so you're looking for U5L8. And I looked through everybody's photos of your Rube Goldberg machines. Most of you seem to be in pretty good condition, if not most of the way done, which is great. And so we've got this week to finalize your machines. My challenge to you this week is to decorate as well. This is not a requirement, this is just for fun. But if you want to decorate your machine, it could be a theme, like a graduation theme. That's what students have done in the past, or like Tiger King or COVID-19 or whatever you want to do. That's more just for fun though. It's not a requirement, but just something if you want to add some parts to your machine that aren't part of the machine itself, but are more like decorative, that's okay. Keep track of your missing assignments as usual. Most of you have been good on that. And you can click on the quiz. So if you open up the quiz on Canvas, same link or same site you went to when you took it, you should now see that it's been graded. Don't freak out if you see like 69 or 72. Does anyone know how many points it was out of?
75.
Is that a 75, right? So 72 out of 75 is an A. So those are high scores. I wrote comments next to questions that I took points off of. So flip through, and if you see anything that was any points lost, I probably offered an explanation or correction of some kind. And again, please email me or ask me questions now if you have any specific concerns. What was it like taking a test written by your classmates? You think it was easy? You think it was hard?
I think it was harder.
I got to admit, some of the questions you submitted, were pretty tough, I thought. But honestly, some of those were the questions that you did really well on, though. Every test was a little bit different, so I'm trying to remember now which questions in this one were particular. But I remember like questions about like the 4 criteria that make a life suitable, like make a planet suitable for life, was always kind of a tough one. Why the surface of the sun emits light. Again, a lot of you understood it's a fusion reaction that is letting go of photons. I was impressed by the answers there. Multiple choice went really well for most of you, which was good to see. I tried to go through and manually correct a few things too. Some of you like spelled a couple answers incorrectly, so the system marked it wrong even though you had the right thing. Make sure I did correct everything that I found, but you can double check me on that if you want. Beyond there, I'm trying to think of any regular trends. For the beginning part of the quiz, a lot of you with the PhET simulation described the new orbit as being oval. And I know I'm being kind of nitpicky here, but technically it's an elliptical orbit, right? We never use the word oval to describe it. Oval is actually more of an egg shape. It's not even. An ellipse is even. It's a symmetric shape. So again, I know I'm being particular there, but that was the correct answer to that. You guys had the blood moon question 20, which again, I got a little particular on in just understanding that it's refracting the light. A lot of you said reflect, but as the light passes through the atmosphere, it was refracted towards the center. That was something I think I mentioned that I brought up at the end of that presentation. So, and extra credit, you just had to mark that Rube Goldberg was a cartoonist. He was also an inventor, but he mostly drew the machines. And geosynchronous orbit is when a satellite sits over a single point. It's good for satellite TV, that kind of thing. All right, and your grades should be up to date if you need to go check on those as well. And this is it. We have about a week left. So if you got missing work or if you have any questions about stuff, now's the time to contact me. Any questions on any of that? Okay, then I would like to introduce you to the case study, which we're going to use to sort of round out our year here. It is called Farming in Space, ? How to develop sustainable crops on Mars. On the tasks list, I would like you to look at step 2, the do now, which is a video of me reading you the introduction. I also put a link to the packet itself, but I would like you to watch the video of me reading through the introduction, and then there is a Google form I'd like you to complete. This is not graded. This is just meant to introduce you to what we're doing, and we'll review it and move on from there. So this is all the do now under step number 2. I'm gonna time this for 8 minutes to watch the video and complete the form. Go for it. Let me know if you have questions or if something isn't working. All right, answers look great. It looks like you all took the main points away. So where are we headed with how many people?
Mars with 100 people.
All right, we've got to keep them alive and healthy. We can assume they're all adults, that there's no allergies, and that they're all in pretty good shape already, starting off. Does anyone know, on average, how long it takes a space shuttle to get to Mars? It was mentioned
Like 3 months.
Yeah, it's months. As I saw a video that said 8 months. It could be 3 months, though. It all depends on the acceleration. But the point is, we're going to ignore that time. So you can assume that the journey is covered. You don't need to worry about food for that or anything else. The thing that we're going to discuss in this case study is what happens when we arrive. So what can we assume is already present on the surface of Mars? What's ready for us?
Atmosphere, like the biodome of 1,000 acres.
So imagine like a giant kind of biodome, which is basically like a little snippet of Earth that we have now built on Mars. It's 1,000 acres, which I know is kind of hard to wrap your mind around, but it's pretty big for like a space station. That would be the biggest thing we've ever built on another planet by far. It's not that big when you think about farmland and like how much farmland we have like here in California to feed people. So we're going to have to think about how we can efficiently use this farmland. We have 1,000 acres, but you can assume that weather conditions, oxygen, water, that's all present, that's all covered. The main thing we want to think about is the crops, right? The plants that are going to use this in the most efficient way possible. So does anyone know what's something that we now use in modern day agriculture to make plants grow a little faster?
Fertilizers.
Yep. So fertilizer is kind of heavy though. So if we're going to bring fertilizer with us, we're going to have to think about, well, then which plants are going to grow the most given only even a small amount of fertilizer. So that's going to be one thing to consider. Does anyone know what yield is? If you want to have a high yield, what does that mean per plant?
Like a large amount of crop. It comes from that.
Like food, like how much edible calories of food are you getting per plant that you're growing? These are all examples of things we need to consider. But before we get to that, I want to take us back even further. We're going to complete 4 parts of this case study. So just to direct you back to the tasks list for today, if you look at step number 3, I have a link directly to the case study. So you can open up the actual packet. Feel free, it's the same introduction that I read out loud in the video. And then there's 4 parts. My goal today is to complete part 1 and part 2. So, and we're going to do this in groups. So here's how this is going to work. I have pre-assigned groups for you. There's a little link. So this is now under step 4, part 1, sustainability considerations. If you click on that first link there, the Science2F farming and space groups, you can see a little Excel doc with the groups named. I'm going to split you into breakout rooms. The first thing I want each group to do is to assign jobs. One of you is going to be the reader. Just like in a POGL, you'll be reading the instructions out loud for the group through Zoom. One of you is going to be the scribe, meaning you're the one that's actually typing a response with the help of your partners to post. And that's the only person who's going to post a response for the group. And there's a timer who's going to keep track of the time. The time will be posted at the beginning of the instructions. We're going to sit 10 minutes for this first part. So the first part is going to be a Canvas discussion. I want you to post to a Canvas discussion board. All of the instructions are there. That's the link in the 3rd bullet point. So again, we're under step 4 in the tasks list. The link is Science2F Part 1 Sustainability Considerations Canvas Discussion. I'm going to break you into your breakout rooms and give you 10 minutes to work on this. Now, I'm going to warn you, my breakout rooms have been malfunctioning. I got them to work in my previous class once, so I'm going to try again. But if you get kicked out of the classroom for some reason or booted out of the whole thing, just be patient. Just try to come back in. I'll keep admitting you. And if it really doesn't work, then I'll just shut down the breakout rooms and we'll just do this individually rather than in groups. But I want to try to see if we can get the breakout rooms to work.
I think I know what the problem is.
Yeah.
It's been happening. It's the update thing. Like,
yeah,
if
so
you have it updated and nobody has it, then it's like no one can get in it. But if someone has it and you have it, then they can get in the breakout.
Okay, yeah, I am updated to version 5. So rooms are open. We'll see what happens. But yeah, if you have trouble, then updating your Zoom might help. So go for it. We'll see if this works. What you guys listed, but let me just hear from a few of you. So it was 2 sets of challenges. One was a sustainability challenge and one was sort of a nutrition and sustainability challenge. So what are some of the things that you guys listed for like the sustainability side? Maybe have the.
Was that the second one?
No. Well, I don't know. What was the first one? I'm forgetting now.
I think the first one was the sustainability one.
Yeah. Well, I mean, technically, it's kind of worded strangely. They're both like about sustainable things, but The first one was 2 challenges in terms of sustainability you would face in the food supply. So what's the challenges you listed for the first one?
Like the crop would take a lot of water. We didn't want too much water.
Yep, water is a key thing. Cameron, what were you going to share?
We were in the same group with the other one that we shared was like, given like we don't know how the seasons differ from the seasons here, so what the yield is compared to how many seasons there are on Mars.
Yeah, Luca?
We talked about how the sun's rays might be different and like less strong, so photosynthesis might react differently and might take longer.
Yeah, I think the intro says it's about 44% of the brightness, and they don't actually go into the day-night cycle, but it is a little bit shorter. And I know it's weird to think, but plants are actually very sensitive to the length of the day, right? Plants are also aware of the seasons. They have circadian rhythms, sort of like we do. I don't think they mentioned in the beginning about whether or not we have artificial lights, but that is something that could be brought along. The question then is where the energy for that comes from, but yeah, those are good things to consider. What about the nutritional side of things? How are we going to keep that sustainable? What were some challenges there for diet?
Challenges is that like we can't just like live off one specific crop. We need a lot of different like nutrients to keep us alive.
Yep. Mm-hmm. Well, I mean, alive, we could definitely feed off one thing. In fact, I hate to break it to you, but currently right now, if living in America especially, does anyone know what most of your food is made of? There's actually only one crop that provides us with most of our food. Anyone know what it is?
Potatoes.
Americans eat a lot of potatoes, but it's not potatoes.
Corn.
It's corn. I know. If you like drinking Coca-Cola, that's corn. Anything with high fructose corn syrup in it, anything with sweeteners in it, which is most things, corn's in almost everything. It's pretty crazy. There's a couple other crops too. You'll cover that in homework. But Hank makes a good point. To be healthy, we need a diversity of foods, which is going to be hard to do if we can't bring that many. Anything else? I know a lot of you are highlighting like staying healthy, which is great. But what about the emotional side? Do you think that's important too?
I mean, if there's a lot of other people there, then we can have at least one shrink there, right?
Yeah, I think that would definitely be necessary. But in terms of food, right, we don't think about it, but food plays kind of a big role in your emotional state sometimes. And so that's also something I think to consider, that while, we could probably create like a protein slurry that would keep everyone alive, that's not necessarily going to keep everyone happy. So anyway, we'll kind of come back to that a little bit. But all right, so as a little interlude, first of all, any other comments or questions on what we just did though? Part one? All right, as a little interlude then, I would like you to watch 2 short Edpuzzle assignments. On the tasks list, this is number 5, titled Food in Space. They're right there. They're each, I think, about 2 minutes or so long. The first one is Science2F Food in Space. The second one is Science2F Growing Food on Mars. Please complete both of those Edpuzzles right now. If you can't get Edpuzzle to work, I have links to just the videos below that. I'm going to time this for 10 minutes, and then we'll come back together to review them. Go for it. Let me know if something doesn't work. What do you think? So what was food like on those first Apollo missions for those astronauts? What did it come in?
Like tubes.
That sound pleasant? Would you like to eat every one of your meals out of like a little toothpaste tube? Squeeze it out. Mac and cheese. Probably not the most, again, kept them alive, kept them healthy, but otherwise not the best experience. So luckily, nowadays, are they able to get fresh fruit on places like the ISS? It's pretty cool. What was the trick for the packaging? Anyone see how they kept those tortillas fresh?
No oxygen.
Vacuum seal it.
Vacuum sealed, yep, and they usually heat treat them before them too. So what's interesting though is, does food taste the same in space? What have they found out? It doesn't. Any ideas why? You remember what we learned about taste in particular? What actually gives us our sense of taste? It's not your mouth.
Smell.
Yeah, it's your nose. And so I don't know the exact, I need to look up and read more about this, but I think that just the way the air flows and moves in when you're in free fall, when you're perceiving relatively weightlessness, no weight, that I think it does change the way that our nose can sense what we're eating. I think it maybe reduces the amount that we're able to actually flow through when we're breathing or something. So I don't know if things taste duller, so maybe we should be eating more spicy foods in space. I don't know exactly what it is, but kind of interesting to think about. That without gravity, things would taste a little bit different.
How like is the food like when he was eating that mac and cheese? They stirred it like 3 times. Is it all cold? Is everything they eat like just like room temperature?
It's a good question. I don't. I would assume they have a way of heating it up, probably a microwave or something like that. But I would bet that yeah, they probably do eat a lot of cold food, just because knowing when you're in a contained environment with oxygen, fire is like the worst thing ever. And so there's definitely any kind of heating element, I'm sure, is strictly controlled. So that's a good question. I would assume that it's, if not cold, then at least it's probably like lukewarm, not how we would eat it, like freshly cooked. It's a good point to make. Yeah, that things aren't probably cooked all that well. All right. The Farming on Mars video. So what did you think? Why can't we just throw seeds into the regolith? What are a couple issues with that? They pointed out a few things. What was just a few issues? Why can't we just throw seeds into the Martian soil?
It's toxic.
Yeah, they don't say in the video it's perchlorate. I think it has chlorine in it. But is the soil underneath the surface pretty good?
Yes.
Yeah, and so I guess maybe in the Martian movie, that's actually what he's doing, is maybe he's digging down and he's using that lower stratum of soil, which is a little bit better. Not only is it toxic, but they also say it's desiccated. So I don't know what that means, that the surface soil is desiccated. It means it's extremely wet.
Dry, right?
Yeah, there's like hardly any water in it at all. Mm-hmm. What about the atmosphere? Is that a good place for plants from Earth to grow? Way too thin, and also way too wet. What else is true about the Martian climate? And we know what the average temperature is. Is it above freezing or below freezing?
Below.
Is it far below freezing? And so that's also not conducive to plants growing. Hence, we have our biodome. It turns out that actually algae baths and growing algae is probably the best way to keep people healthy. Would you guys be willing to eat an algae slurry? A lot of you saying no. Reading over stuff, huh?
If I had to.
Yeah, see, that seemed to be the prevailing thing, was that if it was life or death, okay, but otherwise, like maybe for a little while, but not for like months and years on end. I would assume that if we did have to use that, we would flavor it or change things up or something. But again, it's that happiness factor, right? That, okay, maybe that will sustain you, but how comforted are you by eating those kinds of foods? So those are the things we have to think about. So if we are going to bring crops, then that's the next thing you're going to have to consider. Before we choose the crops, though, we have to select criteria. So this activity, part 2, you're going to be deciding what criteria you're going to use to select your crops, right? Is it the fertilizer use that's the most important? Is it the amount of water that's needed? Is it the yield? Is it the time it takes to grow? You're going to choose your sort of top 5 criteria to select things with. Now, I'm going to try to split us into the same groups again. In my previous class, this is where things went haywire. So again, if you get kicked out or something doesn't work, just log back in. I'll close down the meeting rooms and we'll just do this individually. But on the tasks list, what I'm looking at right now is the last one, number 6. This is part 2, selecting criteria. This is going to be a Google form. So if you click on that link right there, Science2F part 2, selecting criteria for growing foods Google form. All the instructions are there. Same thing, timer, scribe, all that stuff. That's assuming the groups work. So I'm going to go ahead and open the groups up now. But just remember, if something goes weird or if you get kicked out, please just come back into the room and we'll figure it out from there. All right, I've opened the rooms and I can already see we're going to have problems. Okay, so yes, all of you here. Who's missing? So David, for some reason, you're like not on the list anymore. So Olivia, you're also not on my list. I can't even like assign you to a room. Rory. So what I'm going to ask you all to do, can you just try leaving the room and coming back in? And then I might be able to assign you to rooms. So let's try that. Hey everybody. So yeah, we had some issues. I'm gonna try to bring in the people who weren't allowed into the rooms, and then we'll see if we can redistribute you back. And if not, then we'll just go to individual. Sorry about this. This is the same thing that happened last time, but I'm wondering if I could find a workaround for this. Okay, we just need Carmen and David, and then we're good. All right, but I'm not even seeing you in the unassigned thing, so, okay. All right, so here's what we're gonna do. I'm not gonna try to make the groups work because this didn't even work even when I tried to reset it last time. I'm gonna wait for our last 3 people to come back in, and then I'll give you instructions. Okay, rooms are closed. All right, everybody, sorry about that. Again, the breakout rooms definitely seem to be malfunctioning again. So we're gonna do this individually. What I'd like you to do is, instead of the first question asks you your group name and your partner's names, you can just write your name. That's all you need to do, and I'll just have you do this as an individual, the form. So each one of you is gonna fill out the form. Don't worry about doing it as a group. Got it? I'm gonna time us for 10 minutes to work on this, and then we'll come back together. Even if you're not done, it can carry over into homework. So 10 minutes to just work on the form individually. Go for it. Let me know if you have questions or if something doesn't work.